All right, here we are. So ignition timing, typically 20 to 25 degrees before top dead center on compression stroke. We'll talk a lot more about setting up magnetos and timing in another class coming up. But where can I find the timing for an engine?
On the crankshaft.
The data. Type certificate data sheet. Remember that? We looked at one. Where else can I find it?
Overhaul manual.
It is not in the Lycoming overhaul manual. Sometimes. Overhaul manual. I will tell you that confirmation bias is going to kill people. And that is a great example of confirmation bias, because in the directions in the Lycoming overhaul manual for timing the engine, it says, and I can't quote it exactly, but it's something like, rotate the crankshaft till you're on top dead center of compression stroke of cylinder 1. Back the crankshaft off about 25 or 20 degrees before top dead center, some number, and then bring it up to the appropriate spot. What was the number that was printed? 20.
5 degrees.
It's like 20 in the book. It says back it off like whatever. Back it off X number of degrees before top dead center. I should actually look that up. Wonder if I
Why
can.
do they want you to do that?
Because this, let me see. Where do I have this? Let me see. Trying to remember where I put the Lycoming manual. Lycoming, there we go. Oh, it's going to take forever to load. All right, where else can we find it? We'll let that do its thing.
Let's go.
Sometimes the overhaul manual. Where else?
Data plate.
Data plate is correct. Oh, there we go. Hello. Okay. Lycoming manual. These are the things I don't have time for. Let's see. We want... I passed it right up. Ignition system, section 4. Three. 4. Let's see. 4. Spark plugs, retard, magneto, 6-cylinder, 8-cylinder. Let's see, gears, ignition harness, slick, remove, cut, inspect, repair, replace. Reassembly. Installation. Timing the engine. Let's see. Rotate crankshaft in direction of normal rotation until number 1 cylinder is at the compression stroke at approximately 35 degrees before top dead center. So in direction of rotation until number 1 cylinder is on the compression stroke about 35 degrees before top dead center. Clamp the ignition pointer and on the advanced timing mark on the rear of the starter ring. The starter ring gear may be marked at 20 and 25. Consult engine nameplate. Okay, people stop reading right there. So what are my 3 choices for the ignition timing?
35, 20, 25?
I guarantee you, somebody is going to pick up on 35. They're going to time this engine because you're going to do this. And I'm going to come out and check it. And where'd you time it to? 35 degrees. Well, why'd you pick that number? That's what the manual said. You have to read that's confirmation bias. You're looking for a number. You found a number and you went with it. If you timed it 35 degrees before top dead center, is that an advanced spark or a late spark? Yeah, because top dead center is 0. 1 degree is a little bit. 25 is here. 35 is here. 90 is here. So it is very advanced. What that's going to do is cause detonation. The piston is going to burn and you will kill somebody in a matter of minutes on takeoff. It's happened. Happens a lot. So finish reading the directions. Clamp it, timing mark on starter ring gear. The starter ring gear may be marked at 20 and 25. What does it say now? Consult engine nameplate for correct advanced timing mark to use. So confirmation bias. Don't screw up and do that. So what is the timing? So did we see that?
Engine,
It said right there, consult the
Consult engine nameplate.
data plate.
What's the timing? I was told it in a dream.
I don't know that, Joe. So engine data plate. Also service bulletins. Oops, 3. Service bulletins or service instructions are another good place. Obviously, when I talk service bullets instructions, mostly that's a Lycoming thing now, or the M-0 is a Continental thing. So, all right. So we've got that. Don't make that mistake, please. You have to remember that for almost 8 weeks before we get to that class. So, all right. Then we can talk about the firing order of an engine. So we have established that it is going to fire early, about 20 to 25 degrees before top dead center, depending on the engine. Almost all Lycomings are 25. I've never seen one that wasn't, or worked on one that wasn't.
that's information bias, sir.
No, it's not. I said I have never worked on one that, so that is a true statement. If I said all of them are 25, that would be a problem. Because I can clearly remember the type certificate data sheet we looked at yesterday said that the D2 was, I think, 18 degrees. So, according to type certificate data sheet. All right, so firing order. Firing order, that is the order in which cylinders fire. So the order in which cylinders fire. It's designed, firing order is designed to allow the engine to operate as smooth as possible. Designed to allow engine to operate as smooth as possible. That is to eliminate vibration. What's the easiest way to get a smooth running engine?
Leave it off. Run it faster.
Add more cylinders. The greater the number of cylinders, the smoother the engine. Why is that?
Timing. Less stuff. Vibrates.
Less time in between ignition and between
Power impulses. Power impulses what?
Vibration neutralizes itself.
Are closer together. I guess that's one thing I like about Continental over Lycoming. Lycoming will do in 4 cylinders what Continental will do in 6. So Continentals are a little smoother on the smaller ones, up to the 360 cubic inch. So Lycoming goes up to a 360 cubic inch 4-cylinder, where Continental, they start their 4 cylinders all the way down at 300 cubic inch. So 300 cubic inch Continental is a 6-cylinder, and then they have a 360. And so.
1000 cc. V2.
All right. Let's see. B. The order in which cylinders are fired. Because I've got to put that because it's in my order in which cylinders fire. That should go up here. There we go. All right. On opposed engines. What's an opposed engine? What kind of engine are you working on across the street? Opposed. Okay. Anybody have a Subaru in here? My wife has a Subaru. I'm always astonished at how smooth that engine is. I'm not saying about the power, it's just very smooth.
Don't talk too much about her blow head gasket.
No.
They only last about 30,000 miles until they do.
She has 60 on her. So. All right. First thing is cylinder numbering is not standard. There we go. So Lycoming. We can just look at Lycoming engines down here. So 4-cylinder model, number 1 is upper right. The integral accessory drive models that don't, do you guys have an accessory case that came off the top? Which actually comes off the back. That is a standard engine. If it has a built-in accessory case where you just, the whole case is one thing and you split it and that's just, I mean, there's no accessory case, that's an integral. So put the number 1 up at the left front instead of the right front. So most of your standard engines, it's up in the upper right, but it's opposite over here. All 4 cylinders are 1, 3, 2, 4. That I'll commit to memory, and that's the end of it. Because after that, they all start changing. I'm like, I don't have the bandwidth for that, as they say. 6. So let me do this. This is kind of cool. So 4-cylinder goes. Oops, 4-cylinder. 1, 3, 2, 4. 1, 3, 2, 4. 6-cylinder goes 1, 4, 5, 2, 3, 6. And I'm not going to do that at once. All right, Continental. That's Continental. At least they're decent enough to put the number 1 cylinder in the same spot, so it's back here on the back right, and it's the furthest one back. And the firing order is 1, 3, 2, 4. So it's actually a little bit different positioning. And the 6-cylinder is different, so it's 1, 6, 3, because before it was like
1, 3, 5.
like it was opposite.
Like
Yeah, 1,
zigzagging.
3, 2,
5,
5, 4, 5, 4. So a little bit different, zigzaggy back and forth. So
I kind of hate that.
yeah. Where do you find the firing order? Let's talk about what you really need to know. Where is the firing order written down? Cast on the side of the engine almost always. How do you know where the cylinders are? Where's the number 1? If I don't know, where do I find it? It's cast right there. There'll be a 1, there'll be a 3, there'll be a 4 there, and a 2 there. So it's right there for you. And oftentimes the firing order is right there on the engine. So it's easy to find. Not a problem. Never have trouble looking for it. I think that's why I never commit it to memory, because it's always written down right in front of me when I'm working on the engine. So, all right. How about radials?
1, 3, 5, 7.
Okay, first of all, let's dissect this. Which way do almost all engines rotate? For American engines,
Counter.
Clockwise from when viewed from the back.
they turn to the right. They always turn to the right. And I remember that because there is an engine called an LTSIO 360. What does the L stand for? Left. So if you add the left to make it a left, what if there's nothing? Then it must be a right. And almost everything is not. So this is turning to the right. Let me see how you guys looking at it. So if it turns to the right, am I looking at this engine? Am I in front of the engine here, or am I behind the engine? This one right here.
They'd be behind it.
Behind it. This is pilot's view. I told you not to say that, but that's why I said I'm behind the engine here. Okay, so this is what the pilot would see here, which is backwards to me because I'm a mechanic, and so I stand in front of the engine, so this really throws me off. So the propeller is right here on that one when it's on top dead center of number 1. And what's the next one to fire? 3. Then the next one? 5, 7, 9, 2, 4, 6, 8, 1. That's a pretty design. So any radial engine is just going to be odds than evens. And when the propeller comes around, if I move the propeller through an arc to right here, number 3 is going to be TDC. And so it just follows it around. It makes it real easy.
Is that true even on where it has 3 blades in the prop? Does one of them line up?
I think so, yeah. I've never worked on a radial with a 3-bladed prop. I worked on one, but I don't remember doing the compression on it. So, and then it gets very complicated with a twin row radial. You can see that that drawing doesn't work. It fires a front, then a back, then a front, then a back, and a front, and a back. Let's see. I think this is the firing order. They might have done it there. Let me see. Let me see.
It looks like it. Yeah, front and back and front.
Rear row is, no, that's weird. It wouldn't be 2 foot. The rear, I'm not going to hold you this one. The rear is all odds. Let me see if I have an order to. The rear row is all odd numbers. The front row is all even numbers. So that doesn't work. So engines, so be 1, then 12. Yeah. 1, 12, 5, 16, 9, 2, 13. See, it's just all kind of weird. So, okay. We good with that?
Yeah.
Oh, yeah, I wrote that. No, this is the pilot's view because it always screwed me up. I'm like, what the hell? Okay. So that's, we'll come back around to more stuff about the 4-stroke engine. Let's talk about a couple of the other types of engines. Let me see. Cylinder numbering is not standard. Let me see. 4-cylinder. Commit that to memory. 1, 3, 2, 4. Radial is odds. 1, 3, 5, 7, 9, 2, 4, 6, 8. What if it was a 5-row? Or they make five, not 5-row, 5-cylinder. It'd be
1, 3,
1, 3,
5,
5,
3,
2,
5, 2, 4.
1, 3, 5, 7, 2. Did I say 5 or 7?
5.
Oh, we'll go 7. So let's be 9, 7, 5. We'll do that. 1, 3, 5, 7, 2, 4, 6. Not 8. Then 5 be 1, 3, 5, 2, 4. 2, 4. Yeah. Okay. Let's talk about 2-strokes. The 2-stroke engine. Why not 2 strokes? The nice thing about 2 strokes, only take 2 strokes to do everything. So how many times does the crankshaft have to go around to do everything? 360 degrees, which is how many revolutions? Just 1. So you have a power impulse twice as much, which makes them a lot more fun in a dirt bike or something like that, and a little bit noisier. All right, so what is wrong? They are less efficient
They eat up oil.
and more difficult to lubricate. More difficult to lubricate. Often, but not always, fuel and oil are, you know what? Okay. Fuel and oil are mixed. That's true always. Could be you have to do it. So often fuel and oil are mixed into fuel tank. Or you could have oil injected. From an oil tank into, I'll say, fuel for make it simple. So sometimes you have to pre-mix it. You used to have outboard engines were really common. Now they're outlawed, except for on the ocean, I think. So when I was a kid, we had a ski boat with an outboard engine on it. And so, my dad always fill up the 5-gallon gas can and pop open a can of Quicksilver mercury oil and pour it into the gas can, do a little shake, and that was it. The oil and the fuel were mixed up and injected in the engine, and then you go to the gas pump to get gas, and the guy would ask, you want premix or you want regular? And they'd have a little, like 50 to 1, so it's 50 parts gas to 1 part oil. If you get that up and you put 50 parts oil to 1 part gas, it does not work. I had a Honda 2-stroke motorcycle, and they had the same thing, mix up the oil and the gas and put it together.
Leaf blowers.
Leaf blowers, I forgot about yard equipment stuff. Yeah, leaf blowers and stuff like that. I think we had a motorcycle as a kid, dirt bike, where it had a little oil tank, and you'd pour the little same oil, you'd pour it in a little oil tank, then you pour the gas in the gas tank, and then the carburetor would suck the gas out of the gas tank, and then there was something else, a little oil pump that would inject the oil into the gas as it went through, so you didn't have to premix it. So anyway, less efficient. All 4 events, let me see, yeah, less efficient. I already said that. All 4 events, it's actually 5 events really. 4/5 events occur in 2 strokes. 1 up, 1 down. 1 up, 1 down. That's all you get. It's going to use a different set of valve systems. So it's going to use uses reed or rotary valves. All right. Watch the video. Slow way down. The reason why you have to mix the oil into the gas is because it does not have an oil sump and an oil, so you don't have an oil down here, an oil sump that like you guys have on the bottom with an oil pump that picks it up and lubricates and sprays everything. You'll notice that the fuel comes in through here and enters this area around the crankshaft. So the fuel has to have oil in it that goes across here to lubricate these things. So I made it go really slow, didn't I? So all right, so what happens is as the piston is moving up, it creates a low pressure down here. And that low pressure causes it to suck in what was right here in the intake system through a valve that has no camshaft. It'll have a little poppet valve on a spring or reed valves. Reed valves are nothing more than like a thin piece of aluminum that can pop open, if you will, like a reed on a wind instrument, right?
It's just a check valve.
A check valve. That's a good job. Check valve. Okay, so this low pressure right here is happening, drawing this fuel air in that will get used in a minute. Meanwhile, what do we got going on top of the piston? Compression's happening up there. So compression's happening up there. And intake's happening down here. So we got, so there, now we have power is coming down, and as the power is happening, coming down, power stroke, what's happening down here? All this is being compressed. This is not the compression stroke, it's just being compressed, which closes this valve here, and is going to force this through this cavity that just opened up. So this piston is forcing all of the fuel air mixture up through this port into here. Meanwhile, this exhaust port has opened up, so exhaust is going to travel out as intake is going to come in. And the two kind of mix, thus the less efficient, less environmentally friendly. So this has come all the way down, forced all of this up here. Now it's going to turn around and go up. Closed off this port, closed off that port. Now we're into compression, and what happened down here? Low pressure, pulling it up. So there are your 2 strokes.
Why isn't it flat on the top like a normal?
Just to let that little valve on the left-hand side open up.
I think it helps to, yeah, the way that swirls the
Yeah, it
fuel.
helps to let the intake air.
When I took my Honda apart, I don't remember the piston looking at all like
Yeah,
that.
I don't know.
I might want to put that either.
All right. All right, uses reed or rotary valve. Let me see. I think in the interest of time, I'm not going to write all of the little things that I just put right there. Is that fine with you guys? All right.
Because we don't really see those with Aviation.
Rotax has them still.
Rotax
Oh,
uses
really?
those.
Oh, that's why they sound so weird?
The old ones, the older Rotax.
Oh.
Yeah. Not the newer ones, the 914,
How
15s.
old is the older Rotax?
They're discontinued. So I don't know the years. It's like the 400 series, 500 series, something like that.
Aren't they like kind of like paraglider motors?
Yeah, they still use them on lawn chair furniture that flies. That kind of stuff.
You sound like you aren't a fan of paragliders.
Paragliders, maybe. I don't know. I have no intention of getting in one. It's those ultralight things that they fly around down at Lodi Airport. I'm like, yeah, I'm not getting in that.
You're that one that's going snow cowling.
Yeah.
Cardboard box
It was
stuck
just doing
together.
runs on the brain, wasn't even going in the air. It was just.
All right, types of engines. We've talked about them. Now let's we had the horizontally opposed. Horizontally opposed, that is pretty much the most common in aviation now. Even your Rotax are now horizontally opposed. As were the older two-strokes. They were like two cylinders that were inline. Now the Rotax are all horizontally opposed too. So any modern aircraft is really going to have a horizontally opposed engine. So that's the most common in aviation, or modern aviation, at least now. See pros. Pros. They are, thankfully, dependable. Good power. Good power to. Jeez, I cannot get this one to go here. Yeah, it's goop. All right. There's my problem. See, I started to write good right there and just fell apart after that. B. Good power to weight ratio. That means for as much as they weigh, they put out a pretty decent amount of power. This is not my thought here, but they say economical. And I say that's a relative term.
30% of fuel burn, or 30% of fuel burn goes to extra powering the engine. That's economical, all right.
Yeah, low profile. What that means is they're shy. They hide. It is not a tall engine. They're short, right? So, yeah, if you think about your 0320 is really only about that tall. Add the sump in, and that's about it. That's pretty, better than the opening photo with the big V8 stuff. So low profile. What? Yeah, as compared to a radial. I mean, yeah, radials are how big around they are. They're get pretty big. Low profile. I said reasonably free from vibration, so I'm just going to say good vibration. Good vibration. Characteristics, but I don't want to write characteristics. CHARACTERISTICS. I don't know if I can spell that word right. Cons. Cons. What are my cons here? Rear cylinders tend to run hotter. That's not too bad. Out of the book I got, that's really the only negative they had on there. Let's talk about designations. So typical prefix designators. For horizontally opposed engines. This is so we can all speak the same language. So you have an O320 and the O stands for?
Opposed.
Opposed. Well, there's a whole bunch of other stuff we can add on there, and you already know one of them, which is L, which means left-hand rotation. From whose view?
Pilots.
From the rear. Back in.
From the rear of engine. When viewed from rear of engine. Why would you want it to go left?
Push prop.
Twin.
You have
Twin engine. There's not a lot of them. Most twins run dual right hand. Piper Seneca has a left.
I think it's Duchess does.
Okay, I was gonna say I ran out after that one. The Seneca, and then I don't know the other one.
I don't know the name of it. There's a push prop that is a hanger down the way that they're contra rotating.
They're contra rotating because the back one is the other. Put it backwards.
It's a dual engine.
So if that one's left, they're going to run the same direction.
No, but they're running into each other.
Yeah,
So
if
one's
one
a
goes.
right hand and one's a left hand.
Yeah, if you rotate around, it'll.
No, but they're both facing backwards.
Oh, both facing backwards.
It's a double.
Oh, both facing. Got it. Okay.
That could be possible. Just
Is that the Piaggio?
just so it's not-
Yeah, maybe.
I think it's a turboprop anyway.
Piaggio's turboprop.
Yeah. Okay. So anyway, twins will use one of the engines to be a left hand. It has to do with critical engine, which one is the critical engine out. But not all. Most twins, I think, just use both right and like live with it. If you have a T, that would be
Turbo.
turbocharged. That is Lycoming uses that. Lycoming uses that one. How about a TS?
Turbo supercharged. No, turbo standardized.
Turbo supercharged. Continental uses that one. I'm going to put TCM, even though it's not proper. That was Teledyne Continental Motors, which I don't think they are anymore. They're just Continental. V.
Vertical.
Just like that.
Vertical. So the engine, instead of being placed in a horizontal position, it is placed with the drive shaft facing up. Why would you want that? Helicopters. In a vertical installation. What if it's an H? That is for a helicopter.
Oh, what?
So you take your I just lost the word. The very common
Robinson.
Thank you. It's got an R in it. The Robinsons, those engines are not mounted vertically; they're mounted horizontally. But it's designed for helicopter use. So it'd be a HO. Yeah. So it's an opposed engine sitting in a normal position, but used for helicopter purposes. Well, you have to have cooling systems, so fans and stuff like that. So it's just going to have different accessories, different setup. So
Despite having the big fan, it doesn't cool it off as much.
Kevin, why do the rear cylinders run hot on the?
because the air comes in the front and it
Oh.
wants to cool the front ones more. All right, so H for helicopter. A,
Aerobatic.
aerobatic. All right, so Lycoming had the, I should have done I first. Let's put this up here. Lycoming had the AIO, it was a 360s or 540s, I'll make up this part, but they're the AIO. And these were incredibly, then there's AE. What is that?
I'm guessing aerobatic as well.
Aerobatic engine. Okay, so originally, Lycoming, they're the ones that do this, had an aerobatic engine, and they built it so it had a sump on the bottom and sump on top. So, sump on top and bottom. I've never seen one of these. I heard they're incredibly expensive to build because it takes a very special crankcase with a built-in sump on the top. So when you went inverted, all the oil went poop into its own sump down there. And it went back the other way and it went to the other sump. So it was a funky looking engine. I don't have a picture. I saw one time. And then they decided, let's don't do that. Let's just change the design and go to an aerobatic system. So this used aerobatic engine. My notes said solid crankshaft, but it's not because they run constant speeds. So I'll just put uses, did I write the word here? Uses an inverted.
Did they combined an inverted system with an aerobatic engine now? Because my engine's aerobatic, but it's not inverted.
What do you have?
A65.
No, it's,
Continental 65. No, it's in the POH and everything. That's all it says aerobatic.
yeah, okay, we can.
So I was just curious. I'm like, is it like a newer?
Let's talk about that. Okay, so a true aerobatic engine from Lycoming. So you would not get an AIO 540. Now you get an AEIO 540 or 360 or something like that.
All
All right, so in our shop we had a Kristen Eagle, a biplane that was fully aerobatic, and it had an AEIO 360. So what it has is a beefier crankshaft up front, much thicker prop flange, if I'm not mistaken. I think the front of the crankshaft where your two bearings are, that's a little thicker right in there. But most importantly, it has a Kristen Kristen, I believe is the word, inverted oil system, which we'll talk about in oil systems. But what they do is it uses a jar and a ball and they just plummet different. So all engines have a breather off the top. Some of yours don't because they were actually ground power engines to begin with, and that's the difference. But all other engines have a breather off the top, so it just breathes air out overboard. And so when the engine is flying normally, the top is a breather, and it has a breather hose, runs through a little canister, through a check valve, and then out, and then breathes. And then sucks all the oil here. When you go upside down, then it changes it. All the oil goes to the top of the engine, which was the breather. Now that becomes the oil sump, and so it changes that breather into the oil pickup tube, and I'll show you when we get into that stuff. So, but it just has a oil system. So now let's take that as opposed to your engine, which I don't know. Why do you think it's aerobatic?
It's just what it's all the documentation. I'm not saying I do aerobatics in it.
No, I know.
I'm just saying that that's what
They say it's capable of doing aerobatics.
Yeah, so I'm kind of wondering. I'm like, but it's not an inverted system.
Okay, so in his A65, right?
Yeah.
Okay, so at A65, some of those engines, the early Continental engines, did use solid core crankshafts up front. They were heavy. And so, but they don't have a lot of horsepower. Most of them use a wooden prop. You guys have wooden prop?
No, it's metal prop.
Okay, but they were loud. So they're not, it's not a big prop. It's not a lot of horsepower. And when you go upside down, the engine quits
Yeah.
because it's got a carburetor. Carburetors don't run upside down, all the fuel. So it just quits. And guess what happens to oil pressure? It goes to zero.
Yeah, for sure.
It does, and there's no power. But they know you're not going to be doing this for very long because you have no power.
I figured it was just with like maybe like centrifugal force or something like that. Like when you do a loop.
Yeah, so if you do, and I'm not into aerobatics, I hate them, but if you do a proper like aileron roll, you're doing positive G's, the engine doesn't know that it just did that, so maybe that's what it is. Yeah, I didn't know that the 65s were, but certified that.
Use your air quotes.
But they do, like the O2, like there was a 150 Aerobat, it just had an O200 in it, so. I, what is I? I is a big one.
Injected.
Fuel injection. Fuel injection. G. Geared engines. All right, we're going to look in just a little bit about horsepower and how we get horsepower. One of the ways you get horsepower, spin the engine faster. It's a function of horsepower. Problem with our engines, we can only turn them so fast because what do we have bolted to the front of them? Propeller. And as soon as the prop tips go transonic, you're going to set up pressure waves in the prop that'll split it to pieces. So we have to keep the prop subsonic. So that's your limiting factor. So if you spin it, so you can only spin it fast enough because the prop is long, right? And so it's a function of how fast the tips are going. And so if you want to spin your engine faster, you've got to gear it so the engine spins fast and you reduce the prop speed. So get it geared. So that is a gear reduction system. Gear reduction system that allows crank to spin faster and prop to spin slower. Of course, we already talked about O, which is opposed. R. You don't see this one too many. Radial. So remember the exceptions. Exceptions. Older engines used a different system. Older engines use a different system. So if I think about some of the older engines, we have your engine, the A65. We had the C85. We had this, well, I don't need to do all of them. We had the E185, the W670. Let me see, W670. Is it W220? R220? Anyway, A65. So it's an A version. 65 is horsepower. C was the C version. Oops, that should be a C90 or 85. C85. Sorry, that was a C85. That's 85 horse. The E version, 185 horse, and the W670 was
670 cubic inches.
670 cubic inches. Yeah. What was the 220? Continental. I see Continental 220. What was the 220? R220? Jeez, I lost it. Okay. All right. Second part of the designator.
So when you say like older engines, what time frame might that be?
Ooh, when was the first Bonanza produced?
Wasn't that like the, not 40s, it was like the 50s.
Right after World War II, 47.
47. So the E185 was made in 47, and that was designed for the Bonanzas. Fun fact, if I haven't already mentioned it, when they developed the Bonanza, that was really the first, well, you can't answer.
Oh, yeah.
I think you'll know the answer. Bonanza's made by Beechcraft. What was the aircraft that the V-tail Bonanza replaced?
Aerocoop?
Do you know it?
What did Beach make before the
Yep.
Bonanza?
Yep.
Oh, the stagger wings.
Staggerwing Beach. Very rare, very expensive. Had a 985 on the front.
That thing is sick.
A radial 985 cubic inch, 450 horsepower.
Beechcraft Staggerwing?
Yeah.
Beechcraft Staggerwing. It was a
And they're
all fabric.
Dude, it's the like hottest airplane.
Yes.
so gorgeous.
Incredibly labor intensive to build. So all these the pilots are.
It's really unique. It's bi-wing, right? But
All right.
the-
Let's see.
so it's fast.
I'll do it. This is how we're.
Handle the cockpit.
Yeah,
So
the goofiness. The goofiness
It's
of the
like,
top
dude, it's
with
like a
the
little
black
couch in
and
your
blue.
grandpa's house where he smokes cigars. There's like books and everything.
I love
It's
the
like a
way
false
the
voice.
It's
Oh my god, like the
I
outside.
bet you it flies crazy.
Oh, it's fine.
It looks goofy.
Beach Staggerwing.
Yeah, it's only $550.
Yeah.
This is for the model.
I think I saw
Don't look like a model to me.
All right, we're getting way off track, and this is going to go real badly in a few days. So, all right, so the Beach Staggerwing. The point I was going to make is, so Beechcraft decided to make this well, you know what a beach V-tail is. We have one out there. So this is all fabric and wood and labor intensive. You don't know labor intensive till you put fabric on something. It is incredibly labor intensive, all done by hand. Anyway, so Beechcraft decides they're going to make this V-tail aircraft, a monocoque construction out of aluminum, and they need an engine for it because up until that point, I want to say the most powerful opposed engine was the Continental C85, 85 horsepower. So Beechcraft went to both Continental and Lycoming and asked them to produce an engine at 185 horsepower. Lycoming produced a 4-cylinder geared engine that would produce, I forget how many cubic inches it was, that would produce that. And Continental made their 6-cylinder E185. Beechcraft actually gave the contract to Lycoming. Lycoming said, fantastic, we can start production, have your first engine in. And they gave a time frame, and they said unacceptable. Went back to Continental, and Continental says, yes, we can meet your production time frame. Continental got the engine. That's why we don't have 4-cylinder geared engines. So that's why we have the E185. It was built for that. So then from there, Continental made the 470s and 520s, and that's how modern aviation kind of got going. So, yay. All right, so the second part of that designator is what?
cubic inch displacement.
Yep. Usually cubic inch displacement to nearest 10. Like the O200 or the O300 Continental or the 360s, both Continental and Lycoming make a 360. Then they make a whole bunch more now. There's a 240 in here somewhere from Continental.
540.
Well, I didn't get that far. 360. Yeah, after 360, it would go, oh, there's 470. There's the 360, the 470, the 520s, the 550s, 540s from Lycoming. So there's the 541 Lycoming. That's what I mean by usually there's a 540 and a 541. So I forget the difference. And a 541 uses like oil-cooled exhaust guides or something like that. All right, then you have the suffix. Like you have an 0290D. I have an 0470U. But there's two more letters and I forget what they are. That's just additional information about the engine. It may have information as to type of accessory case. Like Lycoming has one engine, the I0360 A1B6D. That's the most complicated one I know. So some of this, like the D, it runs a dual mag. Dual mag is, remember that? The D3000 has one mag, so has a dual mag. Type of crankshaft. Somewhere in this other mess right here, it talks about the counterweights. What kind of counterweights it has on the crankshaft. Type of magnetos. Sometimes a designator from like A to D just might be, well, one has slicks, one has Bendix. It's just the way it came out of the factory. So there we go. Opposed. We have inline engines. The only inline engines I know about, let me see. What do I want? Here we go. There, opposed engines. Ooh, this is something we should know. Well, what kind of engine is this one right here? Who makes that one? Lycoming. Why do you know that?
Color?
Because it's gray. Who makes this one? Continental, because it's?
Not gray.
Not gray, okay. You are expected to know this as a mechanic, just like, I don't know why. I don't know why they just, per mold versus sandcast. So per mold, P-E-R-M-O-L, per mold and sandcast.
That's the color names?
Nope. It's the style of engine. And they're going to talk to you just like, you know, I'd say Lycoming or Continental. You're like, okay, Lycoming gray, Continental gold. But I said, well, no, that's a per mold case. You'd be like, well, okay, why? This is a per mold case.
Which one?
This one right here, this picture.
I can't see what you're doing.
This is Continental.
On the right hand.
It's Continental. This is only a Continental thing.
That's on the Lycoming was the purple.
No, okay. Continental has per mold and sandcast cases. This one has a per mold, has integral or front mount. Oh, it's called front mount alternator. Right there. So you imagine if I took all these cylinders off over here, I would see 1, 2, 3, 4 holes and one that's just a little bit smaller. And then 1, 2, 3 over there. So be like, what is that, a 7-cylinder engine? So per mold has front mount alternator, sandcast, has rear belt driven.
Will sandcast and purple work on that?
Yes. Ooh, that's going to be tough. Lycoming runs all of their alternators from a belt drive off the front. Probably not all, but all the ones I can think in my head. So per mold, that's how you identify it right there. That's a per mold case. All right, then I guess we can talk about inline engines tomorrow. Unfortunately, it's time to go.
I just asked about like